Hi everyone, we are on lesson 10 today. We are starting a new booklet that you got in class. It's called Linear Relations Part 2, and this is lesson 10. So you've got some definitions here to complete today. You're going to use the Math Dictionary link. I also put a link into Google Classroom. You're going to look up these terms and write down the definition. You can do this electronically if you like, or you can write it by hand and then submit it by taking a photo. And then don't forget to add an example. The lesson is on page 2 of the booklet today, and there's a question also on page 3. Page 4 we will do in the next lesson. All right, so today's topic is point of intersection. And essentially what we're going to be looking at is the location where two lines cross or where they meet. That's called the point of intersection. So this is a follow-up from the last lesson when we were looking at graphing straight lines. So we're going to do that again, except today we're going to be looking specifically at where those lines meet and looking at that location. All right, so starting with the first question, the warm-up section is let's graph y equals 2x plus 4. So in order to graph this line, we need the slope and the y-intercept. The slope is always with the x, and the y-intercept is the coefficient or the constant term. So in this example here, we've got our slope, which is 2. And we have our y-intercept, which is 4. And we're going to use those two values to graph our line. So we're going to start with the y-intercept of 4, 1, 2, 3, 4. So we're starting on the y-axis at number 4, and then we're going to use the slope of 2, which is can also be written as 2 over 1 to get our second point. So starting at our y-intercept, we're going to move up 2 spots and over to the right 1. So that's our second dot, and then just use a ruler to add a straight line. Okay, something like that. For the second equation, notice this one is not written in the form y equals mx plus b. So we're going to have to rearrange it. So we want it in the form y equals mx plus b. Okay, so we're going to rearrange this equation. So what we want is we want the y on the left-hand side, and then we want everything else on the right. So start by moving the 2x over to the other side. When you take a term and move it to the other location or the other side of the equal sign, its sign will change. So it's positive on the left-hand side. As soon as you move it to the right, it's going to become negative. So we're left with 3y equals negative 12. That was already there. And now it's minus 2x. And then what we're going to do is get rid of this 3 in front of the y. So notice that I'll just cover that for a second. Notice that the 3y has a 3 in the front, and we just want it to be y. So it's the 3 is being multiplied by the y, and the opposite of multiplying is dividing. So I'm going to divide each of the terms by 3. And then what will happen is the y will have 3y divided by 3. The 3's are going to cancel each other because 3 divided by 3 is 1. So we'll be left with the y on the left-hand side, which is what we want. And then on the right, we'll have negative 12 divided by 3, which is negative 4, minus 2 over 3x. Okay, so that's what we have there. And then, just delete that. We want the x term to be first, right? So it's in this form, y equals mx plus b. So I'm just going to swap those two terms. They are both negative, so make sure when you move a term, you move its sign with it. So in this case, we're going to end up with y equals negative 2 over 3x. And then subtract 4. Okay, so that's the equation written in proper form. And so now we have our slope, which is negative 2 over 3, and we have our y-intercept, which is negative 4. So start by plotting the y-intercept, which is negative 4, 1, 2, 3, 4, so down here. And then the slope is negative 2 over 3. So from your y-intercept, we're going to move down 2 because it's negative, and then over to the right 3. 1, 2, 3. And then add your line, and then there we go. So in this lesson, we're interested in looking at where those two lines cross. And in this case, it's negative 3, negative 2. That's called the point of intersection, which is what I'm going to be talking about in this lesson. Okay, so what we're doing is when we're looking for the location where the two lines cross, what we're doing is we're solving a system of equations, right? Solving a system means that we're looking for a point where that is true for both of these lines, right? This point here is on the red line and on the green line, so it is a solution to these two lines. Okay, so it's a system of equations is called a collection of two or more equations with same set of unknowns, example x, y. Right, so the two equations is called a system of equations. To find the solution, we will find the point of intersection while graphing. So here is an example here, looking at the graph created in the warm-up above, what was the point of intersection? So that was this point right here that I mentioned, so it's negative 3, negative 2. What does this mean, right? What does that point mean? Right? It is the location where the lines cross. It's the solution to a system of equations that satisfy both equations, right? So it's a solution because that point satisfies both equations. It satisfies both lines. Let's check to see if the point is a solution, okay, to those equations. So we know it is because we graphed it, but let's say we didn't have the graph. Let's just say we only had the two equations. We didn't have the picture, and we wanted to check to see if this point is a solution. Okay, that means is this point on this line, and is it also on this line? Because if it is, then that must be the point where they cross each other. So the way I'm going to check to see if this point is on this line is I'm going to sub it in for the x and the y in the equation, and then check to see if the left side equals the right side. So the y is given us negative 2. So I'm putting in negative 2 for the y, and then the x is negative 3. So I'm going to place a negative 3 in this spot here. Okay, so I'll have 2 times negative 3, which is negative 6, plus 4 gives me negative 2. Okay, so because the left-hand side is equal to the right-hand side, that proves that this point lies on this line, right? It's not true for all points. If I picked a different point, right, like the point 1, 2, for example, and I tried subbing this in, if you put in 2 for y on the left side and put 1 in for the x, so on the right-hand side, you end up with 2 times 1 plus 4, right? That equals 6, right? So left side does not equal to the right side in this case. It's because this point does not lie on this line. 2x plus 4, that was our green line. That was this one here, right? So the point 1, 2 is right here, right? And you can see that doesn't lie on that green line. I just subbed it into the equation, and the right side did not equal the left side. All right, so it is not on that line. Okay, let's go back. All right, so I'm going to check to see if this point now is also on this equation. So I'm going to do the same thing. I'm going to replace the x and the y with the correct numbers. So x is negative 3, so 2 times negative 3 plus 3 times y, which is negative 2. Let's see what we get here. We should get negative 12 because the right-hand side of the equal sign says negative 12. So let's see if it's true. 2 times negative 3 is negative 6, and then plus 3 times negative 2 is also negative 6. So negative 6 plus negative 6 is negative 12. So they are equal to each other as well. Okay, so that means this point lies on this line, this point lies on that line. Okay, that tells us that since it's on both lines, that is the location where the two lines cross. Okay, one more example. So this says solve the system of equations by graphing and then prove that your answer is correct. So I'm going to graph both of these equations and then I'm going to check to see if it's on in both equations, if that is the solution. So 2x plus 1, start with the y-intercept of 1 and then use your slope 2 or 2 over 1 to get your second point. Up 2 over to the right 1. Okay, so there's my first line. The second one, y-intercept of -2, and slope is -1 over 1. So down 1 over 1, down 1 over 1. So here we go. So it looks like the solution is right here in this spot. This looks like the solution where they cross. And that point is -1, comma, -1. Okay, so I'm going to, whoops, that was a bit messy. I'm going to check to see if this point is in fact a point on each of those lines, just to justify what I did here. There we go. And same thing I have here. So I didn't need to write that out. Okay, so for this equation here, the left-hand side is just the y, and y is -1. So let's see if the right-hand side equals -1 as well. So 2 times -1 for the x gives me -2 plus 1 is -1. So they're equal to each other. So this point is definitely on this line. And then for the second equation, y was -1 and x was also -1. So on the right-hand side, we have the negative sign, and then the x gets replaced by -1. So we have two negative symbols here, which makes a positive. So we have +1 minus 2 equals -1. There we go. So they're equal as well. So therefore, we can say that our answer is correct, that that point lies on both of those equations, and that is the solution. Okay, so that's the topic that we're focusing on today. You're handing in the homework file, the highlighted questions, and then the definitions on the first page. What I also like you to do for today is you watch the video and you were taking notes, right? You were filling in the handout I gave you. Can you please also take a photo, okay, of your notes and submit that as well? So you're submitting 3 things: your notes, the definitions, and the homework file. So here are the homework questions. You're doing questions 1, 2, and 3. They're highlighted. For the first question, you are determining the equation of each line and then writing down where they cross. That is the point of intersection. Number 2, you're finding the point of intersection by graphing. Okay, so graph each of those lines first and then see where they cross. And then number 3, you're checking which order pair is a solution to the given system of linear equations. So this is kind of like what I did to check, right? You're going to do this sort of thing. You're going to create a little t-chart and you're going to sub your answer that's given into the equation to see if the left side equals the right side. Right, so for question A, only one of these is the correct answer, and I want you to show me which one is the correct one by subbing in the x and the y in each equation. So find the one that works for both lines. And here are your answers. Again, if you need to, well, you should be checking your answers with the solutions I'm giving you here. So from now on, I'm posting the answers only in the videos, so you need to watch the video in order to get the solutions. All right, good luck with your homework and let me know if you need some help.